Every few years, a technology appears that doesn't just divide opinion, it fractures it. Some people see a breakthrough. Others see a red flag. And Chikumbutso RF sits right at that fault line. Because this isn't a gadget. It isn't an app. It isn't even a single machine. It's a claim about how energy itself can be accessed, and that alone is enough to make powerful people uncomfortable. At first glance, the controversy seems simple. Chikumbutso RF is said to use radio frequency interactions to power systems in ways that appear to bypass conventional energy inputs. No fuel, no visible charging, no obvious depletion, and that immediately triggers resistance. Not because energy harvesting is new, it isn't, but because of the scale being implied. Small RF harvesting exists in sensors and low-power devices. That's accepted science. What's controversial is the suggestion that similar principles could be extended beyond milliwatts into machines, vehicles, or infrastructure. That's where the story stops being technical and becomes philosophical. Because modern energy systems are built on a single assumption. Energy must be generated, stored, and consumed. Chikumbutso RF challenges that sequence. Instead of generation first, it suggests interaction first. Instead of storage, alignment. Instead of consumption, continuity. To supporters, this is elegant. To critics, it sounds impossible. And impossibility is where controversy thrives. Engineers who've reviewed demonstrations often split into two camps. One side points to the lack of transparent measurements, independent verification, and standardized testing. Those concerns are valid and serious. But the other side points to behavior that doesn't line up with fraud either. Systems that run too consistently. Demonstrations that don't rely on spectacle. Claims that, while bold, are oddly restrained. That tension between insufficient proof and persistent anomaly is what keeps the debate alive. If Chikumbutso RF failed loudly, it would be forgotten. If it worked clearly, it would be embraced. But it does neither. It exists in a narrow, uncomfortable space where dismissal feels premature and acceptance feels reckless. And that's only the technical side. The controversy deepens when you look at where this technology is coming from. Not a major lab. Not a defense contractor. Not a Western research institution with layers of credibility built in. It emerges from the margins. And history shows that when disruptive ideas come from outside accepted centers of authority, they're judged more harshly, not because of the idea itself, but because of who presents it. That doesn't make the claims true, but it does explain the intensity of the reaction. Because if Chikumbutso RF were validated, it wouldn't just revise engineering textbooks. It would challenge who gets to define the boundaries of science in the first place. The controversy isn't confined to labs or technical forums. It spills into economics, politics, and global strategy. Because energy isn't just a physical resource. It's a lever of influence. Nations, corporations, and even individuals base decisions on availability, cost, and control of energy flows. A technology that bypasses conventional generation doesn't just threaten power plants or batteries. It threatens power structures themselves. That's why reactions have been cautious, even measured. Few dare outright dismissal. Fewer still dare endorsement. And yet, whispers persist. Whispers of vehicles operating without fuel. Whispers of infrastructure-independent grids. Whispers of devices running indefinitely, seemingly defying known limits. Each whisper draws skeptics and believers closer to the same table, if only to argue, probe, and observe. The tension is heightened by secrecy. Unlike mainstream tech, which is dissected in conferences, patents, and white papers, Chikumbutso RF appears selectively. Demonstrations are controlled. Details are scarce. Measurements are often proprietary. That selective visibility fuels imagination and suspicion. Some experts suspect exaggeration. Others suspect misinterpretation. Yet another group suspects there's a principle being demonstrated that the world isn't ready to codify. And that's the essence of the controversy. It's not just the physics. It's not just the engineering. It's the collision of possibility with expectation and the discomfort that arises when reality doesn't fit neatly into either. Observers who have followed the demonstrations note one recurring theme. The system behaves consistently. Not dramatically, not spectacularly, but persistently. Persistence without visible consumption is the anomaly that cannot easily be ignored or explained. And as more eyes turn to it, the pressure grows, not to validate, but to understand. Because in a world built on limits, something that seems limitless is more than a curiosity. It's a challenge that asks, if this works, what else might be possible? And that is why Chikumbutso RF will continue to spark debate, fascination, and inevitably, scrutiny for years to come. Conchu from where you stop, don't end the script /. And the scrutiny isn't just academic, it's strategic. Because when a technology has the potential to operate independently of conventional energy inputs, the implications ripple far beyond laboratories. Industries begin to calculate risk. Governments begin to assess security implications. Investors begin to reconsider where capital flows. Every demonstration, every anomaly, every unexplained consistency adds weight. It's no longer a matter of curiosity. It becomes a potential pivot point in energy, transportation, and even defense. That's why Chikumbutso RF inspires both hope and hesitation. Hope, because it hints at a world where devices, vehicles, and infrastructure could operate without the limitations that currently govern them. Where remote regions gain access to energy and mobility is no longer tethered to supply chains. Hesitation, because such a shift threatens established hierarchies. Corporations built on fuel, batteries, or grid control watch closely. Regulators wonder how to classify what doesn't fit existing rules. And scientists demand reproducibility in a space where demonstration, not data transparency, currently dominates. It's a delicate balance. One misstep, and the technology could be dismissed forever. One breakthrough, and it could rewrite assumptions about energy itself. And that tension is why Chikumbutso RF remains controversial. Because it exists in a space where human understanding struggles to catch up with observation. Where persistence, rather than spectacle, is the signal. And where the consequences of validation, social, economic, and geopolitical, loom larger than the machine itself. For every skeptic who walks away shaking their head, there's a believer quietly analyzing, calculating, imagining the possibilities. And that is exactly the environment in which revolutionary ideas often survive, not in public acclaim, but in the quiet, relentless pressure of possibility meeting reality. And as the world watches, quietly or otherwise, the conversation shifts from if to how. How can such a system be verified without full transparency? How could it be scaled beyond prototypes? How might it integrate with existing technology without disruption, or with strategic disruption? Those questions are as much political as they are technical. Energy independence isn't just about convenience. It's about leverage. Nations that control energy influence markets, supply chains, and even diplomacy. A technology that sidesteps traditional energy sources challenges that balance. Which is why Chikumbutso RF attracts attention not only from engineers and inventors, but also from analysts, policymakers, and corporate strategists. Every demonstration, every anomaly, every persistent operation becomes a data point in a much larger conversation about the future of energy. And yet, despite the scrutiny, one thing remains constant. The system continues to perform. Quietly. Reliably. Without fanfare. It doesn't seek validation. It simply exists. That is the paradox that fuels both fascination and frustration. Skeptics demand measurable proof, while supporters point to behavior that defies conventional explanation. Neither side can fully claim victory, yet both are compelled to observe. Because when a machine challenges the assumptions we take for granted, assumptions about energy, consumption, and limitation, it doesn't just disrupt technology. It disrupts belief. And belief is harder to change than any technical specification. As the conversation expands, the implications begin to take shape in unexpected ways. Could vehicles truly operate without recharging? Could infrastructure adapt to energy systems that are no longer dependent on fuel or centralized grids? Could regions long excluded from reliable energy finally gain autonomy? And the implications extend even further than energy or mobility. Education, industry, and healthcare. All sectors rely on predictable access to power. When that assumption is challenged, opportunities emerge where once there were limitations. Remote clinics could operate without relying on fragile supply chains. Schools could power technology in areas long deemed off-grid. Small businesses could thrive without energy costs dictating their scale. But with opportunity comes tension. Established players, energy companies, governments, and industrial stakeholders face a new reality. Their models, built on scarcity, could suddenly be outdated. Investments planned over decades may need reevaluation. Policies crafted to manage supply now collide with a technology that sidesteps supply entirely. And this is why the debate around Chikumbutso RF isn't just technical, it's geopolitical. Interest isn't limited to local or regional actors. International attention quietly follows each demonstration. Analysts watch for patterns, for replication, for signs of real-world scalability. Every anomaly is cataloged, every success measured against decades of scientific expectation. Yet, despite the pressure, the system continues quietly, almost deliberately. It doesn't court headlines. It doesn't demand recognition. It simply performs. And that is the essence of the controversy. The technology behaves in a way that cannot be fully dismissed, yet cannot be fully embraced. It exists in a space where observation challenges assumption and where persistence is more powerful than spectacle. For those following the story, the question is no longer whether Chikumbutso RF works, it's what the world will do once it's undeniably proven. And that is where the story of Chikumbutso RF reaches its first full circle, not with a conclusion, but with a question. A question that extends far beyond machines, demonstrations, or headlines. If a technology can operate outside the rules we've long relied on, how will society respond? Will it be embraced as a tool for progress, reshaping energy access, mobility, and opportunity across continents? Or will it be resisted, dismissed, or contained by those whose influence depends on scarcity? For now, the aircraft flies, the systems hum, the anomalies persist, and the world watches, curious, skeptical, and undeniably aware that a new chapter in energy and innovation is quietly unfolding. Because some technologies don't just change what we do, they change what we believe is possible. Chikumbutso RF is one of them.